Okay, Calc, this is the second half of the Chapter 7 review. We started yesterday and we did the front side. And so now we've got a few problems doing on the back side and the story problems also to go along with it. So here we go, 25. When it says expand, so we did some yesterday where we were condensing stuff together, like putting stuff together, like adding means multiply and subtracting means divide, and that's kind of what we're doing in reverse for expansion. So you'll still have log base 10 for these pieces, but the x and the y are being multiplied together. So when I separate them out, I'll have log base 10 of x, and it'll be plus log base 10 of y squared. And then there's one more thing that I can do, and it is that any exponents that you have in your log functions or whatever, you want to make sure that they come down in front, okay? So you shouldn't have any exponents in your final answer. So last thing is log base 10 of x plus 2 log base 10 of y, and that is how you pull that apart, okay? All right, so moving on, 26. This fraction means that you are dividing, and when we divide, we separate them out into two pieces as subtractions. So log base 2 of x minus log base 2 of 5, and I think that's all I can do. That's it. There's no other exponents to move or anything like that, so he's good to go. Okay, 27. This one has a little bit of a tricky thing to it. So beware. This division, we're going to separate it out into subtractions. So I have log base m of a minus log base m of yw. But then this guy I have to separate, and that's multiplication, which means I have to separate them as addition. So I have log base m of y plus log base m of w, and then I've got log base m of a here. Now, what am I writing? Log base m of a minus. Okay, now, if I leave my answer like this, it's technically not quite right because I want to make sure that the negative goes for this piece and goes for that one. So I'll have to put like either parentheses or brackets, or you could just change this plus to a minus and get rid of your brackets. But that will show that both the y and the w are in the bottom. So that's the tricky part to that. You have to make sure you either have parentheses or you distribute your negative through, or brackets or whatever you choose to do, or distribute your negative through, because otherwise it looks as though this is on the top now. So just keep that in mind. If you have two pieces in the bottom, you have to use parentheses or distribute the negative, okay? All right, we've got 3 questions where it says solve each equation. All right, so this is going to get kind of icky. Some of these, like this is an exponential function, and what I want to look at to begin with is like 4 and 12. Those two numbers are bases of my exponential function, and if I can get them to be the same number, like writing this as like 4 squared or something, that is the option that I probably want to go with. But in this case, 4 squared isn't 12 or 4 cubed isn't 12. So my only option is to either put a log in front of both sides or put an ln in front of both sides. I'm just going to do ln. It doesn't matter which one you use. But when you have a log there, then that means that this 3x can come down in front. And so I have 3x times ln of 4 equals ln of 12. And then what I can do is to solve for x. I'm trying to get x by itself. I can divide by ln of 4. Actually, I can really divide the 3 and the ln of 4, but I'm just going to divide the ln of 4 to begin with, just so that we don't get too messy. Okay, so I'll have 3x by itself equals an ln of 12 divided by ln of 4. I got 1.79-ish, and then I'm going to divide by 3. So x is going to be equal to, I got 0. They want rounded to the nearest 10,000th, which is 4 decimal places. So 5975-ish, okay? Now, keep in mind that, I think I've talked about this before, that ln of 12 divided by ln of 4 is not the same thing as ln of 3. Like, you can't just reduce those two, because it's an ln on the top and an ln on the bottom. So that is not the same thing. Just keep that in mind. All right, moving on to 29. Here we go. 6 and 18, if I can make those the same base, like if I can write this number as 6 squared and like this as 6 of to the power of x plus 2, then I could just set these two equal to each other, but 18 is not 6 squared or 6 cubed or anything like that. So I have to ln both sides or log both sides, it doesn't matter. Then this x plus 2 can come down in front. So x plus 2 times ln 6 equals ln 18. And I'm going to divide by ln 6. And I've got ln 6. And I've got x plus 2 is equal to whatever that decimal number is. Okay. ln divided by, and I got 1.6131 or something like that. I'm going to subtract 2 from it, so x is going to be equal to negative 0.3869 is what he will round to, 4 decimal places. Okay. All right, so these aren't terribly hard, but there's just kind of a few steps to them. Some of you guys can do this without writing every single step out, and that's fine. Go for it, but there's how that works, okay? We've got e as our base over here and 120 as our base over here. We're trying to solve for x, and in this case, ln. If I ln both sides, this makes it really nice because the 4x comes down in front, but also ln and e will cancel with each other. So the only thing I have left is 4x on this side and ln of 120 over here, okay? Now, when they cancel, I say that they cancel with each other, but when they cancel, they make 1. ln of e is 1, so this is really 4x times 1, which is just 4x. So, I mean, they do cancel, but they cancel out to become 1. And then all I have to do is to solve for x, I just have to divide by 4, okay? Now, make sure that you're doing ln of 120, closing your parentheses and dividing by 4, because 120 divided by 4 is 30, but you don't want to be taking ln of 30. You want to take ln of 120 and then that number divided by 4. There is a difference. So let's do 120 ln divided by 4. And I got as an answer 1.1969-ish is what the rounding should be, 4 decimal places. Okay, 31. Okay, same thing here. I can ln both sides and the x comes down in front. So x and ln of e is 1. So x times 1, or just x, equals ln 25. And then all I have to do is type that one in. I don't even have to divide by anything. I got 3.2189, something like that. Okay. All right, 2 left and then some story problems. Here we go. We've got ln of 6x equals 4. All right, now it's hard to know what to do on some of these problems because, like, where do I go from here? And so I always go with the strategy that if it is a log function, like an ln or a log, and you can't do anything more, like if there was a 2 in front here, I could divide the 2 over to the other side, right? But there's no more algebra I can do. I can't do anything with the 6 because he's trapped inside the ln. So once I get to a stopping point where I'm like stuck, if it's a log function, turn around and make it exponential. And if it's an exponential function, you turn around and make it a log, like up here. You know, there's nothing else I could do with this e, so I had to insert a log in front of it or rearrange it and make it a log. And that's kind of how that works. So I'm going to make this an exponential function. And I just remember that ln is the same thing as log base e. Okay, so I'm going to say e to the 4th power equals 6x. That's how I flip it around. This base to this power equals this guy, okay? And then what I can do is I can just type in e to the 4th power into my calculator and divide that number by 6, okay? And that should give me what x is. So that's just my always go-to is if you get stuck, like flip it to the other form and see if you can do something with it. So I get that divided by 6, and I have 0.0997. If I go 4 decimal places is what I got, okay? So just a little strategy. 33, okay? So again, we have ln of this stuff, but I can add the 5 over to start with. So let's do that first. ln, the x plus 3, the plus 3 is trapped inside of the ln, so I can't like subtract the 3 over, like that's not gonna work. So I can just do the 5 for right now, and I have that. And now I'm stuck again, so I switch him to an exponential function, okay? And again, ln is the same thing as log e. So when I switch him, he becomes e to the third power equals x plus 3. And then I'm going to take whatever e to the third power is, and I'm going to subtract 3 from that at the end. So let's see what I get. E to the third power. And then minus 3. And I get 1 point, no, I don't. I get 17 point something. 17.0855 is what I get for my final. Okay, so a little bit of work to each one of those, and I know some of you guys can do that, some of that stuff in your head, and you skip steps, and that's fine. Just be careful skipping steps that you don't do something wrong. So that's what all the work is written out. But if you guys can do it shorter than that, more power to you. Just make sure that you don't skip too far ahead and do something wrong. Okay. We've got some story problems here, and they give me a formula on some of them, but let's see what we got. All right, the population of rabbits in an area is modeled by the growth equation of this guy. Okay, so the time, the population is dependent upon the amount of time that has elapsed. So P is in thousands. Okay, so we're talking about thousands of rabbits. And T is in years. Okay, how long will it take for the population to reach 25,000? Okay, be careful of this. This 8 right here is usually like your P value, or like your starting value. And the starting value, we're not starting with 8 rabbits, we're starting with 8,000 rabbits, because our numbers are all in units of thousands, okay? Which means that P of T, which is the after amount, this is the after amount, is not going to be 25,000, it's just going to be 25. So that was kind of a tricky thing that they threw at us, because if everything is in units of thousands, we have to just make that 25. Otherwise, we're going to have a weird answer for T. Okay, so now we're just solving for T here, and we're working backwards. So kind of like what we did up here in like number 30. Okay, we have an exponential function. But first and foremost, I have to get rid of the 8. So I've got to divide the 8 over. Okay, and 25 divided by 8 is 3.125. So here's where I'm at now. 3.125 equals e to the 0.26 t power, okay? And then I can do an ln in front of each one, right? And this comes down in front, but then the ln and e cancel. So I've got ln of 3.125 equals 0.26 t. And last thing, to solve for t, I'm going to take whatever ln of 3.125 is divided by 0.26, and that should give me a time period. And the time period is in years. Okay, so these bunnies are multiplying over years. Okay, ln of 3.125 divided by 0.26 is we'll go 4.38 years. We don't necessarily have to round to 4 decimal places on these story problems because we're doing years. So 4.38 years is how long it would take for 8,000 bunnies, because that's my starting amount, to become 25,000. So yeah, that's a decent amount. All right, compound interest 35. They do not give us a formula for this equation. We have to know this one, and this is one that you probably should know. It's compounded continuously, okay? And that is the PERT equation. Oop. RT goes my exponents. So A is the after, P is the starting, R is the rate, and T is the time, okay? If you need to write that down, go for it. But you are depositing $8,500 into an account. That is my starting amount. So that goes in for P. E is just E. We know E is a number in the calculator. 3.5% interest, but that means that it is 0.035. So I want to put it in like that. T is T. We're solving for how long, which means T is what we don't know. And then it takes for the money to triple. Okay. Triple, if I'm starting with 8,500 and I'm wanting that to triple, that would become 25,500. Now, some of you guys like to skip this step probably, and if that makes sense to you, go for it. The very first thing that I'm going to do is divide by the 8,500, which is going to give me 3 over here, right? So if you guys want to just start with 3 equals e to the 0.035t, you go for it, because you know that this number is going to be 3 when you divide. If that number was like, if it would say how long would it take for the money to double, this would just be 2 over here, and then I would have no number in front of my e, right? Because it's like, that's what I'm going to do first, is divide it over, and it's going to become that amount. So if you want to start there and skip a step, you go for it. I'm going to ln both sides, so ln and e are going to cancel, and this is going to come down in front. So I have ln 3 equals, down, I make it look like it's coming down in front. It's still on this side of the equal sign though. 0.035t, and now I'm going to divide by 0.035. Okay, and if you're having any troubles in your calculator, it's probably because when you open up, like if your calculator opens up a parenthesis on the 3, you need to close it off before you hit divided by 0.035. So if you're not getting the same number when you type it in as I do, that's probably the issue, is that you need to close off your parenthesis for your 3. So ln of 3, or maybe I'm just doing it wrong, I don't know. That's totally a possibility as well. I got 31.39, and this is, it doesn't say it doesn't say what our units are in, but compound interest, the formula for compound interest is set up to default to years, okay? So like when they give you an interest rate, they're automatically assuming that that interest rate is an annual interest rate of 3.5%. So we'll just say years for our time, unless they specify differently, okay? All right, last one, meteorology. They give me an equation here that I'm looking at, but let's see what it's talking about. I'm gonna write it down here. S equals 93 log D plus 65. Okay, one more thing I'm going to add in here. This is a log base 10, right? There's no base on it, so I'm going to assume that it's a base of 10. And I'm going to add that in there. The speed of the wind. So this is wind speed. Wind speed. I'm just labeling my stuff. Near the center of a tornado and the distance in miles. This is distance, that the tornado travels are related by this model. On March 18th of 1925, a large tornado struck portions of Missouri, Illinois, and Indiana with wind speeds at the center of about 283 miles per hour. So that was my wind speed. I'm going to plug 283 in here, approximate the distance traveled, okay? So I've got 283 equals 93 log with a base of 10, if you want to leave that in there. And I'm going to unwind this to try to solve for it. And the first thing I'm going to move is I'm going to subtract the 65. So 283 minus 65. I could do that in my head, but it's been a long day, so I'm just going to try to just do it. 218 equals 93 log base 10 of D. And I'm going to divide by 93. So I guess I need that 218 in my calculator anyway. And I get like 2.344-ish equals log base 10 of D. Okay, now we're stuck. Now what do we do? Crap. Well, here's the rule again. This is a log function, right? And when we get stuck, we make him our exponential function. We switch him to an exponent, okay? So the base of my log is 10. Usually we have this written as like log base 10 of D equals 2.344. So if you need to, you can flip him around and rewrite him. Now let's make him an exponential function, okay? So the base is going to stay 10, and now the exponent is 2.344 or whatever we had, and that's equal to D. And then all I have to do is take 10 to that power, and that will give me the distance. So I'm going to, I wonder if I can use the full decimal. I'm going to say 10. Yeah, we're going to do that. I'm going to go back to the full decimal, 218 divided by 93. Yeah, because it's a big long decimal, and then I'm going to take him 10 to that power, and that is going to be like 220.84, and distance is in miles. is that distance. Okay, so if you got an answer that's slightly different than mine, it's because you probably typed in the 2.344. I just used the full decimal again. So yeah, so there's that. Okay, so definitely doable on the story problems. It's just the same thing as what we were doing up here in these 6 solving, but that should give you enough to work with for the test tomorrow. Okay.